Okay, welcome back. We're on page 405 now, talking about network access control. And so here's the idea. Let's say that you wired everything like I just told you. You don't have wires hanging. Everything's been terminated and tested and all hooked up. And so somebody sees an empty Ethernet port, an RJ45 connector port on the wall, and so they just grab a laptop and grab a cable and just jack on into it. What's to prevent that from happening? Well, there's a thing called port security, that you could have it so that the machine either has to have some validation, or perhaps it has the MAC address has to be, something that it knows about. I mean, there's lots of things you can do. So MAC authentication is pretty cool, but it is pretty doggone easy to spoof the MAC address of your device, particularly over the radios. Okay, in fact, if you go to most phones, it says, hey, here's the current MAC address. Would you like me to change it? It's like, what? In Ethernet cards, in the old days, it was on a chip that you mounted on the card, and then the card was plugged into a PCI slot or something. And you couldn't change the MAC address at all. But now, spoofing a MAC address, that's pretty easy, So authentication, maybe you need some sort of a name and password or something. Or better is a certificate. In other words, each machine, when it's provisioned, has a certificate. And so when you jack into a machine, it's going to say, who the hell are you? Let me see your certificate. And if you answer correctly, you get on. And if you don't, you don't get on. Okay, so location services. One of the cool things about VLAN is, I mentioned that a subnet could be huge, right? You could have like 100 people on the third floor. With a VLAN, it could tell you that you're in the engineering department, therefore you're on the east side of the building. So, I mean, that's not much. But some VLAN strategies will tell you physically where you are. Okay, that could be helpful. I mean, I'm not talking about emergency services. It's just that, some guy calls up to the help desk and says, hey man, I've had trouble with my printer. You won't have to say, wait, where are you? Because you know where they are. They're on the east side of the building. Okay, that kind of thing. We're talking minor stuff. Okay. Page 406, wireless network. Yes, wireless is incredibly convenient. You don't have to connect anything. You just turn on your device and you're ready to rock and roll. Okay, so for the physical infrastructure for wireless, you need a wireless access point. You need to have good enough coverage. Now, in your home, you typically have one wireless access point. Maybe you have a repeater. If you have a really big house, you might have a doodad that plugs in. It just repeats what your wireless access point is doing. Okay. But in the corporate world, I need to have lots of wireless access points. And I need to configure it so that if I'm on like my phone and I'm walking from the east end of the building to the west end of the building, and I move, just like a cell phone, I move from one cell tower to another cell tower, same scenario. When I move from one wireless access point to another wireless access point, I want that to be a seamless transition. Okay, that's how that works. You need to have sufficient bandwidth. And a lot of this has to do with, I can control my part. I can control what I have on my wireless access point and how it's connected. But I can't control what you got on your phone. You may have an older phone that's using, older version of Wi-Fi 4, 802.11 AC, whatever. I have no way of knowing. Okay, so what happens if you don't get? Let's say I'm on my phone and I only get 2 bars, but I can still connect, right? So what happens in that scenario? Well, what happens is my connection is slower. Let's say I had, I'm making these numbers up. Let's say I had a 100 megabit capable wireless system, but I'm too far away from the access point and I got 2 bars. I'm probably getting 50 megabit per second. So that speed is only guaranteed when you're standing right there next to the wireless access point, not when you're further away. Okay, just saying. Okay. So one more time, the logical connection when it comes to wireless. So most people would have like a VLAN if you had, wireless allowed. It would be for the company, right? The company where you would have your stuff, maybe all those machines that are joined to the domain. You could have employee kind of thing, and then you have guest services. Now, what we did back in the day in the Army is, we had obviously a very secure setup We had port security turned on, so you couldn't just jack into something. But when people came to visit, like in the conference room, it's kind of assumed that they could want to be able to connect to the internet. So we had a private wireless access point that had nothing to do with the Army whatsoever. It was basically, through Spectrum, and provided a wireless access point. It didn't connect to there was no connection whatsoever. We ran two networks. We ran an Army network and then a Spectrum network, and the two never ever touched. Okay, so if a visiting salesman came to our conference room, they could fire up their laptops, pop on in. In fact, quite frankly, we didn't even care if they had a password on the thing, because we don't care. The only thing you can get to is the internet. Can't get to anything else. Okay, so that's kind of a good way of thinking about it. So the employee VLAN would be kind of sort of like what we just talked about with at the university when you go to EduRoam. So I want to connect my wireless device. It says, hang on a second, let me see if you are vetted. Yeah, here's your name, here's your password. Yes, we trust you. Bing! And we pop on in. So one VLAN would be for the physical machines hooked up to the LAN. Another one for those people who are trusted over wireless. And then a third choice. Wireless that is not connected to anything whatsoever, and you no password required because you're not connecting to anything other than the internet. Okay, so what about roaming between a VLAN? In that scenario I just talked about, hardwired machines that are on the domain, wireless machines that are operated by honest-to-God employees, and then guests. There's no connections between those three. None. Now, here's a weird story that I see this in textbooks a lot. They talk about, well, if the VLAN gets, overwhelmed, it could spill data from, one VLAN to the other. If the physical switch gets overwhelmed. And I'm thinking, come on, I don't believe that. I mean, if I was building a VLAN scenario and my switch became overloaded, I would, instead of being promiscuous and spilling data from one VLAN to another, I would most likely just have it shut down. I mean, I don't know. Just sounds strange to me. Okay, so now we're going to talk about data center on page 408. So what's the difference between a data center and a server room? Well, we're really only talking about density. Server room probably has, I don't know, in my day we had, 6 or 7 servers in there. But in a data center, you might have 6,000 or 7,000, machines in there. So it's really about density. Obviously, we need lots and lots of bandwidth. Okay. So one of the things they talk about is where to put those IDFs, the intermediate frame. So one way of doing it is at the top of each 19-inch rack, you could put your own patch panel there. Okay. And it just kind of makes it easy. This patch panel could be on the back side of the rack, so everything goes connected to the, all the machines in the rack get connected to this one thing, and then there's a fiber optic cable going over to an MDF, probably in the same room, okay? So that's one way of thinking about it. And then another way of thinking about it is, here is, the by the way, this is called a TOR, top of rack. I know, of course they're going to have an acronym. A top of rack patch panel, or perhaps a top of rack switch, or top of rack router. It's just that, the top of the rack is where those things go. So this one talks about, here's the giant patch panel for everything. This is probably like an MDF kind of a scenario. Clearly we're not talking, well, I don't know, it's kind of hard to tell from the photograph there, but it could be those are individual machines in there, but that's one heck of a lot of cables. So a core switch, and I'm using the word core because that's the terminology that Cisco uses. Cisco uses this idea of a core, and I'm not going to get into Cisco philosophy, but that is their naming conventions. So you could have a core patch panel and a top of rack core, and then this would be what's called the network fabric. We'll talk about this again. Again, using Cisco terminology. So here's an example of, a top of rack switch for each one of these 19-inch racks. Then the fabric switches, which is the back end, or that connect all these guys together. So if this 19-inch rack wants to talk to that 19-inch rack, it has several ways of getting there because these things are, this fabric has lots of redundancy built in. Okay, kind of makes sense. Okay, from a logical perspective, we're talking about data centers got to separate subnets from the rest of the building. I mean, clearly, anything else going on in the building, their stuff inside that room is going to have to be separated. That's fairly obvious. And so there's a case study on page 413. I'm not going to go too much, but it talks about, the primary network and a secure network and a DMZ. That's kind of what we like. We want a connection inside the server room. We need to have a secure connection, and then we need a demilitarized zone, a DMZ, a dirty section. So when people come off to the internet, they only get this one piece of your network, not the whole thing, just this one little piece. And probably all it has is like a web server and a DNS server. I mean, and maybe a database server if your web needed it. That's it. Okay, nothing else. So people coming in off the internet only get to see a tiny, tiny portion of your network inside the DMZ. They don't get to see anything else. Okay. So the wide area network on page 413. So now we're talking about stuff that don't belong to you, most likely. So now you need to talk about a demarcation point. So I'm hiring a company to come provide me internet services. Okay. So I need a huge internet pipe. And so they're going to come in and mount something on the wall someplace. And then they're going to say, from this point on, from this point back belongs to us. And then from this point forward belongs to you. So if there's something wrong with this part, you call us. If there's something wrong with this part, you're on your own. Okay, that's the demarcation line. Okay? Now, they talk about some star topologies and stuff. This is kind of weird. So this is one way of doing it. I have a main office and I'm connecting them all together. And so this field office wants to talk to that field office. It has no choice but to route the traffic to the main office. That is very common, believe it or not. But you can kind of sort of see there's an awful lot of potential for failure, right? Makes sense, right? So here's another scenario. This is called a multi-star. So now there's not just one connection. I mean, the Texas office can connect to the secondary or the main, okay? Or maybe it's this, that one and that one. So they get these two. That's probably better for redundancy, right? Okay. And then a ring topology. To tell you the truth, ring topology is not really normal these days. I mean, I've seen this, in the old days, there was a cool little protocol that used this. Those days are gone, and so I rarely see ring topology. But anyway, it's all about redundancy. It's about how to configure these things so that there's not just one path. Okay. In a ring, basically a break anywhere and everybody's down. Okay. Okay, so some technology on page 417. So there's a thing called a virtual private network, a VPN. Okay. That's not the same thing as a VLAN, virtual private network. So in the old days, if I was in some office, let me get back to here. I was in the main office and this guy was across town. He's, 10 miles away. What you would do is you'd call up the phone company and say, hey, I need a leased line. And what they would do is they would hard code a line that didn't have to go through any dialing or switching. That, a copper pair at this end would show up as a copper pair at that end. Okay, I mean, we're talking about physical connection here. I mean, you could, put voltage on the line and see voltage pop up over here. That's how you did it. And nowadays, that's just not happening. Not at all. Now, if you're in a town that has, for example, Spectrum, where everyone has Spectrum, and there's most likely, a Spectrum cable going somewhere in the vicinity, you contact them and say, I'd like a leashed line, and they're going to nod their head saying, sure, no problem. They're not going to give you a leashed line. They're going to give you something that's equivalent, actually better. They're going to give you a virtual private network through their network. So their network has lots of traffic through it. And what you're doing is you're buying a private little connection inside their network. And it's virtualized, virtual private network. So no one else can see the traffic that's in there. Okay, we're coming up on the 15-minute mark. You guys know how this works.